Okay, let's talk about what's called pseudocode, or an outline for computer science, the sort of outline that's sufficiently detailed that you can use it to create a program from it. So that's our learning goal, is to learn how to make an outline, or how to start making outlines for computer science. So here's our task. We're going to write a program, and it's going to ask the user to enter 1 if they want to enter numbers, and 2 if they want to enter animals, and it's going to print an error message if they enter something else. Now if they enter 1, it's going to ask for another number and print whether that number is positive, negative, or 0. And if they enter 2, it's going to ask for a type of animal, and it's going to print mammal if they enter dog, reptile if they enter lizard, and not dog or lizard otherwise. Otherwise they're going to print 1 or 2, not 1 or 2. So there's kind of 2 levels to this menu. First we're going to ask, do you want to give me numbers or animals? Then if they say they want to give me numbers, we have another task. If they say they want to give me animals, we have another task. Otherwise, we're going to say, hey, you didn't enter 1 or 2. Those were the numbers I asked for. So in order to figure out what code we need to write, we're going to need to build an outline. And you can think of this as if you're writing a paper. You wouldn't sit down to write a paper without having an outline. You would come up with some outline of what you want the paper to be about, then you would start writing. Full disclosure, I've taught FP 3 times now, and I've learned that in fact this is not always true. It's perfectly possible for students to try to write papers without an outline. It does not usually go well, so we're always going to recommend you write an outline. Programming is not particularly different. The grammar is a little bit different between writing a paper and writing a program, but the general idea of having to have some idea what you're trying to do ahead of time, that still matters, and it matters a lot. So the term you'll hear in computer science for an outline is pseudocode. Pseudo meaning kind of or sort of, and code for code. So sort of like outlining a paper, when you're outlining a paper, you're not really writing complete sentences. Maybe you're having just titles, and you've got maybe bulleted lists, and you want to include enough information that when you sit down to write those complete paragraphs or complete sections, you can figure out what you want to write based on the notes or the bulleted lists you've got there. So you want enough detail so that you can fill out the details, but you don't want to have to worry about all of the details. Now this process is actually, there's a cognitive psychology term for it. It's called chunking. And it's one of the key differences between expert and novice problem-solving approaches. There's actually a really good, you can actually find this online, it's called How People Learn from the National Research Council, and this is one of the results that's kind of showed up over and over again. If you look at the way experts solve problems and the way novices solve problems, when a novice sits down to solve a problem, for example, going back a couple of slides to the outline of our task, if a novice were to sit down and solve this, they would not be able to divide this up into pieces. They'd kind of think about the entire task at a time. Whereas if an expert were to sit down and solve this, they would break it down into chunks. They would say, well, this thing here, this is a chunk, and then this kind of like top level menu is a chunk, and as I'm solving one chunk, I don't need to worry about the other chunks because they don't really have anything to do with one another. So jumping back ahead to where we were, this chunking process, it's actually a very, very important high-level cognitive skill that you're going to want to develop, very useful in computer science, but also useful in basically, any number of other fields, especially for writing. So there's 2 basic approaches to designing a program. There's the top-down approach, where you start with the overall structure, and you're kind of going to gloss over the details of subcomponents. You're going to chunk those away and say, well, I need some code that does this, but I'll worry about that later, and I'll write this other stuff first. There's also bottom-up, where you figure out, well, I know I need this subcomponent, so I'll just write that first. And then I know I need this other subcomponent, so I'll write that next. Then once you have all the subcomponents you need, you can kind of start combining those together to build up bigger structures. So we've got top-down and bottom-up are two basic ways to build code. Now, most of the stuff we're going to do is going to be top-down, so it's critical to figure out what you need your program to do before you start coding. In other words, don't write code if you don't fully understand what you want the code to do. The second thing, you want to write small testable pieces of code. So you don't want to write 50 lines of code and then think, well, let me try compiling this and running it and see what it does. You want to write a little bit of code, run it, see that it works, and then move on to write the rest of it. So you're going to test part of the functionality, you're going to verify that it works before you try to write all of the functionality, and pseudocode can actually help you break down things into this process. So everyone can outline their ideas and what they want things to do. This is not some magical process. Sometimes it looks magical to a novice to see the way experts break things down, but experts weren't born being able to do that. Nobody like pops out of the womb saying, hey, let me create knowledgeable chunks that I can recombine together with subcomponents to make a larger program. It's a learned process. So a lot of people will say like, oh, I don't like programming, or I'm not good at programming, or I just don't get it. And a lot of times what that means, at least what it's hard not to hear, is somebody saying, well, I don't really like having to be organized, or I've never had to do anything where I really honestly have to pick a plan and refine that plan and try to stick to that plan very carefully in order to get stuff done. And I'm not really sure how people get through high school without having to learn how to do this, but thinking back, I wasn't great at this when I got to college, and even in college it took me a while to learn this because nobody sat me down and explained to me that this is what I needed to learn, and I kind of wish somebody had. So maybe this will be useful to you, but this idea that thinking that, oh, well, I don't get this, or I'm not good at this because it's really hard and it's forcing me to be very organized, that's a good thing. You want to be able to be really organized. You want to be able to outline things well, because it's going to make you more efficient at, all sorts of things. I mean, even stupid things like having to, move out of your dorm room at the end of the year. You kind of want to have a good plan for that. Anyway, I've lingered too long on this topic. Moving on. This kind of summarizes the reason why everything I've just said is important in kind of a funny way. It's a famous programming proverb. Hours of coding can save you minutes of thinking. And so the reason that's funny is a lot of programmers, and I'm certainly guilty of this, are perfectly willing to sit down and just start coding without really having a clear sense of what I need the code to do, because coding is kind of fun, and once you kind of understand the basics, it's not particularly difficult. But if you don't really know what the code is supposed to do, then you're kind of wasting your time. So you need to spend those few minutes ahead of time outlining things and figuring out what you want the code to do, and then code it up. Or you can just sort of write a bunch of code for a while and kind of hope for the best, but chances are that's going to take a lot longer than if you were to just come up with an outline ahead of time. So the key parts of a pseudocode outline, you have to keep in mind, you're not writing Java code at this point. Just like when you write an outline for a paper, you're not writing full paragraphs, you're not even writing full sentences. So your pseudocode outline is kind of like bullet points. Now you want to indicate the structure somehow for what things need to look like. You don't necessarily need to use brackets, you can just kind of indent things to show where the blocks are. The focus here is on the logic, not on what all the functions look like. So a high-level outline for our task that we're trying to accomplish could be, well, I know I need to enter a number, so I'm going to say, well, number equals enter a number. And then if the number's 1, I need to do the stuff I need to do when the number's 1. Else if the number's 2, do the stuff I need to do when the number's 2, else print the error message. Now, if you think about this task I'm trying to accomplish, this kind of outlines that top-level menu. I've got 3 possibilities, numbers 1, numbers 2, or it's not 1 or 2. And then if it's 1, I need to do some stuff. And if it's 2, I need to do some stuff. But I'm not worrying about that at this point with the outline. Now, other things to note, this is obviously not even close to the correct Java syntax for a scanner. This is just kind of a note to myself to say, well, do the stuff you need to do in Java to enter a number. This is another key component of pseudocode. At this point, you are not interested in all of the details of how a scanner works. You're just interested in the overall logic. If you start thinking about the scanner before you've done this much, then since you've just learned the scanner within the last couple of days, a lot of your cognitive load is going to be sucked up by trying to figure out the scanner, which is not going to leave you a lot of brain processing power left over to figure out the outline. So if you figure out the outline and push off details about how the scanner works and how the syntax of ifs looks like until later, you can at least get that outline worked out and then fill in the details later. Now, suppose we take this and translate it to Java code. It's probably going to look something like this. We're going to say pick a number, 1 for numbers, 2 for words or animals. It's like, obviously, later than it should be. I shouldn't record this late because then I yawn during things. We're going to read in this number. So here we have looked up how the scanner works. We're checking it against 1. We're saying, now enter a number, checking it against 2, and then here we've got our else saying, okay, well, you didn't enter the right thing. And then we've left ourselves notes. If you sort of note here, these comments are just saying, well, put the code here for what we do if somebody's entered numbers, and then put the code here if they're looking for words. So we're not filling in those details, we're just kind of leaving that for later. Now, subtask number 1, well, ask for a number and print whether it's positive, negative, or 0. I know how to do that. I can just fill in all of this code. Now, I need to call it num2, because where is this going to go? Going back a slide, it's going to go here, and I've already got something named num, so I can't have something else named num. Now, this code here, I can actually test this in a separate program, but I don't have to. If I can kind of figure out how to write this much, I can go ahead and take this and just kind of dump it in here. So here we've got, 1 for numbers, 2 for words. Here we're reading in our number. Once we see that it's 1, then we're just plugging in that code here. This was subtask number 1 that we had one of those comments for. And then if it's 2, we've got the other subtask, and then our other, else, and so on. Interestingly, that was the last slide. So the idea here, the take-home message, write up an outline of just what the logic needs to look like using whatever syntax you're most comfortable with. Could look like this, can look like anything that you want it to look like, but the idea is just figure out the logic, the flow, so you know exactly what you need the program to do. Then you gradually start translating all this stuff that's kind of written in your own language into more specific Java code. Okay, great, thanks.